Hello student, let's try to understand the topic derivation of Arrhenius equation student. So Arrhenius given a equation student, empirical equation according to Arrhenius. Rate constant they have given k is equal to AE minus AE power minus EA upon RT student, right? Here some term will be used student, that is the formulas, which formula is going to use, that we are writing ln is equal to 2.303 log one thing, natural logarithm, and this is base 10 student. Now the one thing is this, and the other things if you can write ln a minus ln b is equal to ln a by b. ln a power n, you can write in the different way. Suppose you are having ln a power n, so n ln a. Same formula will be applied in the term of log also. So this formula is going to be used student, right? So taking natural logarithm both the side, so what will be there student? ln k is equal to ln a. Student, one more formula is there, ln a into b is equal to ln a plus ln b. Keep in mind. Now this formula, if you closely look this formula, here is decimal is there. So what is going to happen student? ln a plus ln, what will be there student? E power ea upon rt. This is there. Now student, this is this we are going to this formula we are going to use, ln a power n is equal to n ln a, like that. So what we are going to do student, we are simplifying this one. ln k is equal to ln a minus ea upon rt ln e, and ln e is equal to what is there student? 1. So what we can write student? ln k is equal to ln a minus ea upon rt. Case 1. At t1, rate constant is k1. Rate constant is k1. So what we can write student? ln k1 is equal to ln a, Arrhenius constant, minus ea upon r, activation energy constant, r is constant. Here is the t1 student, equation 1. Case 2. So what is the case 2? At t2, rate constant, what the point they are talking about, rate constant is k2. So what is there student? ln k2 is equal to ln a minus ea upon rt2. This is the equation 2. Equation 2 minus equation 1 we are doing. So what we can do, at the different temperature, from 1 and 2 you can do, from equation 1 and 2 we are subtracting. So ln k2 minus ln k1 is equal to ln a minus ea upon rt2 minus, then it will be bracket ln e minus ea upon what is going to be rt1. This is now ln k2 minus k1, so it will be there student ln k2 upon k1 is equal to ln a minus EA upon RT2 minus ln A minus minus, that is plus EA upon RT1. This is there, student. Now one thing you can do here, ln A positive and negative, that is going to be cancelled out. So ln K2 upon K1 equal to minus EA upon RT2 plus EA upon RT1. Positive sign is bigger than the negative sign. So ln K2 upon K1, you are taking EA upon RT1 minus EA upon RT2. Take the common, student. So ln K2 upon K1 is equal to EA upon R is common, student. So 1 upon T1 minus 1 upon T2. Now what we can do, student, here? We know, student, ln is equal to 2.303. This is the log. This one we are applying. So 2.303 log K2 upon K1 equal to EA upon R. Here is 1 upon T1 minus 1 upon T2. This is there. Now 2.303, let send this 2.303 to other side, student. So what will be there here? Log K2 upon K1 equal to EA upon 2.303. This is the R. Here is, student, 1 upon T1 minus 1 upon T2. This is the what the required equation, student, Arrhenius equation. Or you can write here log K2 upon K1 is equal to activation of energy upon 2.303 R. Here is what will be there, student, T2 minus T1 upon T1 T2. So this is all about the answer, student. Thank you very much for watching, students. This is the derivation of Arrhenius equation. You can go the systematic, you will get the answer, student.